Today we'll finish to talk about the t-test series, so we're going to talk about the pair sample t-test. In this case we are going to use a different data set, given that the one that we have been using for the past videos doesn't suit to perform a pair sample t-test. As usual, you can download this data set from the blog and perform the analysis by yourself. The pair sample t-test is used in repeated measures or correlated groups design, in which each subject is tested twice on the same variable. A common experiment of this type involves the before and after design, and it is used to determine whether the mean difference between paired observations is significantly different from zero. The participants in the study are either the same individuals tested on two occasions or under two different conditions on the same dependent variable. So, for example, you have a design where you want to see if the consumption of X or Y drug can affect the number of calories that the participants eat during the period of 1 week, or you can see the difference between the mean scores of grades, which is actually the one example we are going to use here. So you can see here we have two variables, one pre-test and one final, and the label is that this first variable is before brain camp, which is the name of this fictitious new teaching technique, and the second variable is after brain camp. This is we were going to see if there is any statistically significant difference between the scores of the same individuals tested in two different points in time. When are you going to use a pair sample t-test? What is it for? So mainly the four reasons to use a pair sample t-test are to determine if there are changes over time between two related groups, to see if there are differences between conditions, between measurements, or between matched pairs. Now, in a pair sample t-test, as in any other statistical analysis, there are some assumptions that should be met. So, the first assumption in this case is that you need one dependent variable that is measured at the continuous level. This means it's ratio or interval. So, example of variables of these types are time, intelligence, grades, weight, and so on and so forth. Secondly, you need one independent variable that consists of two categorical related groups or matched pairs. So by related groups, I'm just talking about that the two groups are not independent. And as usual, two assumptions is that your data is normally distributed and you have no outliers. Now, for the sample t-test, for the paired sample t-test, the assumption of normality in the outliers is tested on the differences between the paired values. This is really important. You are not testing these assumptions of normality and no outliers on the values of the pair groups themselves, but on the differences between the groups. So in order to accomplish this, you just need to compute a new variable. I'm going to show you right now how to do it. So you just need to come to transform, compute new variable. Now let me right click here and select display variable names only, and the target variable is going to be called differences. We're going to take our final variable, click here on the minus button, then the pretest here, and click OK. So as you can see here in the output window that we have already, that the program has performed the action, we need to go to our variable view, and you can see here that a new variable has been created. Now let's go to data view, and you can see here the differences between the scores. Remember, these are our participants, in this case 30. So for example, participant number 10 has a difference between the before brain camp and after brain camp teaching technique of 24. We are going to perform the normality and outliers assumption on this new variable. So let me quickly just show again how to do it. Remember that you can also check the video on detecting and dealing with outliers and testing for normality. Now, something important before we start with the testing of assumptions is that, as you can see here, our new variable differences as a measure of nominal type. We need to change this to scale. So now let's go to Analyze, Descriptive Statistics, Explore, and we are going to move differences into the dependent list. We just want the plots, we don't want statistics. Let's go to plots, select dependent factors together if you want. In this case it's really unimportant since we have only one variable here, and make sure you have the normality plots with test box selected. Click on continue, click on paste, so the syntax editor will open. Select the syntax and click on run. Now we have here the results of our analysis. Remember, since we are testing for normality, we need to check here in the Kolmogorov-Smirnov test, and here the significance. If we have a value greater than 0.05, that means that our data is normally distributed, and as you can see here we have 0.14. Also, you can check the plots, and you can see that the information alongside this line is actually really well distributed. We don't have any point, for example, here or here. Everything is alongside this line, and we can see here. And here's the box plot. We don't have any outliers. And again, if you are unfamiliar with this, please make sure to check the video on detecting and dealing with outliers. Now we have just determined that we don't have any outliers, that our data is normally distributed, so we can start with the actual procedure for the sample, for the per sample t-test. Click on Analyze, Compare Means, and select the per sample t-test. Once again, let me just right click here and choose display variable name so we have this shorter. Select Final, and you see the variable goes here. Now select Pretest and click here. If you want to change, you say I want first the before brain camp variable here, then you just have to click here, but let's leave it like that. In options, we want our confidence interval at 95, but if you want you can change it to 99, but let's just keep this default. So I'll continue, click on paste again. Since we already had opened the syntax editor, as you can notice, didn't pop out, so we need to look for it. Here it is. Select the new syntax and click on run. So this is a very straightforward table to interpret. We have our mean scores. The after brain camp score is 86 and the before brain camp score is 66.5. So you can see that there was an increase in the scores between the 2 points in time before and after the new teaching technique. We have this information here, but we want to check this per sample test table. So we have our mean, our standard deviation, and standard error mean. We want to check the significant two-tailed box. We want, if we want to see if there is a statistically significant difference between the two mean scores, we want a value here that is less than 0.05. As I explained in other video, in this case, if you see just zeros, that doesn't mean that you have an actual zero. This means that you have a 0.0005. So in this case, we can see here that there is a statistically significant difference between the two mean scores of our test. Additionally, you perhaps want to check the effect size of your test. So simply you have to divide the mean by the standard deviation. So in this case, 19.5 divided 9.9, and we have an effect size of 1.96, that is below 2, and this is called the Cohen's d value. And as reported by Cohen in 1998, a value of 0.2 is small, 0.5 medium, and 0.8 large. So as the effect size in this case was 1.9, we can conclude that there is a large effect. But once again, this is something, calculating the effect size is something that perhaps you don't need to do. And some people believe that the Cohen's d is a bit unstable, but still, I just wanted to show you how to do it in case your supervisor or your teacher or on your statistics class wants you to perform this. So now you know it's a very, very easy process. So with this, we can conclude this video and this series on t-tests. Thank you very much for watching and have a great day.